Moving to the next question, and here we are going to look at the topic of refraction of light, and you are told that a student does an investigation to determine the refractive index of a rectangular block of a transparent material. The student uses the equipment in the investigation: a ray box, rectangular transparent block, protractor to measure the angles, a pencil to draw the outline of the glass block, and the paper where is going to lay the glass block. So the student is going to lay the glass block on a piece of paper and then trace the outline of the glass block. Then this student is going to place a ray box at an angle, and the ray is directed to the normal. Then it will place a mark where the ray is getting entering the glass block and where the ray is exiting the glass block. So we'll join the straight line through the normal from this point to this point. Then this angle here is measured using a protractor, and that will be recorded as the angle of refraction. And this angle above the glass block is called the angle of incidence. Then in that way, the student can be able to collect the data, and one of the way can be able to determine the glass block, the refractive index of the glass block, is by finding more angles of incidence and the corresponding of angles of refraction, and then find sine I over sine R. Then from there he will plot a graph of sine I against sine R, and that will give us a straight line. Then the gradient of this straight line will be the refractive index. That's one way you can be able to do it. Another way can be done is whereby the student is going to repeat the angle of incidence and do repeat of angle of refraction, and then find the average of those angles, and then use now the formula sine I against sine R to determine the refractive index. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. You need also to know that refractive index is 1 over sine C, where C is the critical angle. Then if you are given the refractive index as 1.2, we are going to say sine C is equals to 1 over n, where the refractive index is 1.2. Then sine inverse of that refractive index is going to be 56 degrees. So the sine inverse of 1 over the refractive index is going to give us 56 degrees. Another concept that is very important for you to remember in IGCSE Physics refraction is total internal reflection, TIR. Total internal reflection is a phenomenon which occurs when light travels from a dense medium to a less dense medium is completely reflected back into the dense medium instead of refracting into the second or less denser medium. So total internal reflection occurs when light traveling from dense medium to the less dense medium completely reflect back, and this occurs in the following conditions. Total internal reflection will only occur if the ray is traveling from the dense medium to a less dense medium, i.e. from water to air or from glass to air. Incidence when the angle of refraction is 90 degrees. So let's go back to angle, what it is. You're going to place your protractor like that, and the angle is going to translate to 24 degrees. Moving to the next question, we are told to draw the ray in which the way the ray is going to leave the glass block. So what to realize that since the angle is 24 degrees is less than the critical angle, and the critical angle for that glass block was 56 degrees. We had gotten it this part. Let's go back and let me show you. We had gotten the critical angle to be 56 degrees. But the angle of incidence, in this case, we have gotten it to be 24. So meaning the ray will be refracted, total internal reflection will not take place because the angle of incidence in the dense medium is less than the critical angle. The next topic that was tested is the topic of pressure, and we are told that there are two. The diagram shows a submarine at rest underwater, so meaning upthrust and weight are equal. If it's at balance or at equilibrium, it's neither moving up or down. So we can say the upward force and downward force are equal. And we are supposed to give the name of the force that was acting downward, which is the gravitational force, because already we were told one of the force was upthrust force. Moving to the next question, it says that state the formula linking pressure, density, and the gravitational field strength. This is going to be pressure is equals to density times gravity times the height of the liquid column. And then you are supposed to calculate the pressure of the water at the point 38 meters below the surface. Yeah, some other question you may be told to include atmospheric pressure. So if they had given us atmospheric pressure, we were to get this pressure then plus atmospheric pressure. But this question, it was just straight and straightforward. We are supposed to state how air exact pressure on the walls. Remember, air molecules move randomly. According to Brownian motion, the air molecules move randomly. They collide with the walls of the container. As they collide with the walls of the container, they exert a force, and the force exerted per unit area is basically pressure. Then you are supposed to also calculate the pressure of air in the storage tank at 18 degrees Celsius. And remember, for you to use this formula, you have to change temperature to Kelvin. So that will be the temperature in degrees Celsius plus 273, and that becomes 275. If the temperature in degrees Celsius was 2.5, temperature in Kelvin here will be 275.5. And if it's 18 degrees Celsius, it becomes 291. Then we can now be able to apply the formula P1 over T1 is equals to P2 over T2. So substituting that into the formula, we're going to get our value being equal to 433 kilopascals as that case.